5G Xhaul is a Phase 1 collaborative project funded by the European Commission under the framework of the 5G Public-Private Partnership. The project consortium comprises 12 partners, including several operators, vendors, small-medium enterprises, research centers and universities.
The objective of the project is to address the requirements of future 5G networks, where the increased demand for mobile connectivity introduced the need for a large number of smaller cells at specific locations. This makes traditional distributed radio access networks costly, inefficient and unsustainable, introducing the need for new and more centralized architectural models. To solve this issue, the cloud radio access network architecture has been proposed, but it requires high bandwidth, low latency transport links known as fronthaul.
In view of these challenges, 5G Xhaul focuses on the development of a converged optical and wireless network solution offering both fronthaul and backhaul services. This converged infrastructure is controlled by the flexible and scalable 5G Xhaul control plane. The combination of these technologies makes the overall solution able to jointly support end-user and operational services.
To enable these novel concepts, the 5G Xhaul consortium developed, firstly, a novel data plane architecture integrating together a variety of heterogeneous wireless and optical technologies and the required data plane interfaces across domains. Secondly, high throughput and low-cost wireless backhaul technologies, including millimeter wave and sub-6 technologies. Thirdly, a hybrid optical transport network integrating active and passive technologies. These include the time-shared optical network supporting elastic and fine bandwidth allocation, and passive optical networks adopting wavelength division multiplexing for increased capacity. Fourthly and finally, a flexible and scalable control plane relying on the software-defined networking architectural model that controls both wireless and optical technologies.
The 5G Xhaul technologies have been demonstrated and tested in various partners' laboratories, and as a final activity, they are also integrated in the citywide testbed in Bristol. This final demonstration aims to showcase the overall 5G Xhaul architecture and perform integration of the novel optical and wireless technologies.
In addition, it aims to verify the control plane features and evaluate the end-to-end performance in a real network environment. The specific functionalities that will be shown include a converged infrastructure supporting jointly fronthaul and backhaul services. Second, transport network slicing, creating independent and isolated network across the common infrastructure. And third, the use of SDN control to enable automatic recovery from failures.
This diagram depicts the 5G Xhaul physical infrastructure deployed in the Bristol waterfront. We have used this deployment to demonstrate the 5G Xhaul multi-tenancy and SDN fast reroute capabilities. For this purpose, we instantiated two tenant slices between Wapping Wharf and at Bristol, where we host the WDM Pono and use that connect us to the core network. For each slice, two HD videos are played, where the first slice follows a 60 GHz link into MShed, a sub-6 link to Perros Bridge where there is no line of sight, and two more 60 GHz links to at Bristol, both for uplink and for downlink. The second slice follows instead two 60 GHz hops into at Bristol, also for uplink and downlink. To demonstrate the fast reroute capabilities, we broke the sub-6 link while quickly redirecting the slice 1 traffic uplink and downlink through the path now shared with slice 2, without the HD video streams being affected.
The time-shared optical network has been proposed by High Performance Network Group, University of Bristol, as a dynamic optical network solution to offer high bandwidth and low latency connectivity in support of the 5G technology requirements and provision jointly optical backhaul and fronthaul services. Its network implementation consists of field programmable gate array optoelectronics platform integrated with advanced optical components to enable high performance processing and transparent switching and transport. The timeshare optical network baseline technology has been extended over the course of the 5G Xhaul project to support multi-Ethernet clients for backhaul and common public radio interface integration for fronthaul services. The extended timeshare optical network is the first multiple protocol programmable interface that meets the key 5G performance indicators. This demonstration introduces the time-shared optical network 5G Xhaul implementation to address the varying front-haul capabilities and the backhaul requirements and interfaces that the 5G Xhaul transport network needs to support. We have employed Xilinx VC709 evaluation boards for the implementation. The configuration contains time-shared optical network edge node 1 and 2 connected to 3 clients comprising 2 Ethernet and 1 common public radio interface port. The CPRI link is native CPRI and supports up to 4.9 gigabit per second in accordance to the 5G Xhaul baseband unit and remote radio head implementation. In the upstream scenario, edge node 1 aggregates to 4.4 gigabit per second Ethernet into one 8.8 gigabit per second flow and sends both CPRI and the aggregated Ethernet packet to edge node 2. Edge node 2 receives the packets from the Ethernet and CPRI ports. The Ethernet packets are segregated to 2 ports based on the VLAN and CPRI traffic maps the CPRI client. Each client is looped back on node 2. The downstream scenario functionality is the same as the upstream. This technology is an essential component of 5G.